The universe we see, the stars that shimmer, the galaxies that drift like silent islands in a cosmic ocean, these are only the surface. They are the outer shell of something far more intricate, far more structured, and far more mysterious. Behind every glowing star lies a deeper order. Behind every spiral galaxy lies a hidden blueprint. And behind the entire cosmos lies a code, an invisible architecture that holds everything together. When we look into the night sky, we assume we are witnessing randomness, stars scattered by chance, galaxies floating without purpose, space expanding into a meaningless void. But none of this is true. The universe is not random. It is not chaotic. It is not a scattered collection of cosmic accidents. It is a design. Not a design made by intention or consciousness, but a design born from the laws of physics, laws so elegant, so consistent, and so interconnected that they create a pattern that repeats across all scales of existence. In this documentary, we journey into that hidden pattern. We travel beyond the light, beyond the visible matter, into the structural skeleton that underlies the universe. This journey will not take us to distant planets or exotic suns. It will take us into the geometry of the cosmos itself, because the universe is not made of objects. It is made of structures, patterns, flows, networks, geometries that weave space, time, matter, and energy into a unified whole. And the most astonishing truth is this: even though we cannot see these structures with the naked eye, they govern everything we do see. Let's begin with the largest scale imaginable, the cosmic web. Imagine zooming out from the Milky Way farther than any telescope can reach. You leave behind the stars, then the star clusters, then the entire galaxy itself. Soon, the Milky Way becomes nothing but a faint glimmer among billions of others. And then something remarkable happens. You begin to see a pattern emerge. Galaxies are not scattered like confetti. They form long, thin filaments, cosmic threads stretching across millions of light years. These filaments connect at dense intersections known as nodes, where hundreds or thousands of galaxies gather in colossal gravitational cities. Between these filaments lie vast, empty regions, enormous cosmic voids where almost no galaxies exist at all. If you could hold the entire observable universe in your hands, it would look like a three-dimensional spiderweb, an impossibly large lace of glowing threads woven through darkness. This cosmic web is the first clue that the universe has an underlying code. Because no one arranged this structure. No cosmic architect laid out the pattern. The web emerged naturally from the laws of physics. Gravity pulled matter into lines. Dark matter formed invisible scaffolding. Gas flowed along filaments until galaxies were born, and the voids expanded like bubbles between the threads. It is a structure created without intention, but filled with purpose. But the cosmic web is only the beginning. As we zoom in, something remarkable happens. The patterns we see at the largest scales begin to resemble the patterns on much smaller scales. This is the essence of a fractal, a design that repeats itself across different levels of magnification. Fractals exist everywhere on Earth, in the branching of trees, in the cracks of dry soil, in the currents of rivers, in the patterns of lightning, and even in the structure of the human lung. Nature has a habit of repeating her geometry. And the universe is no exception. The distribution of galaxies resembles the branching of neurons in the human brain. The clustering of matter mirrors the patterns of electrical networks. The cosmic web itself reflects the same mathematical rules that govern rivers, clouds, and coastlines. It is as if the universe has one favorite language, geometry, and uses it everywhere. Why does this happen? Because the laws of physics apply at all scales. The universe behaves like a vast fractal system, shaped by self-organizing principles that repeat endlessly. Gravity pulls matter into specific patterns. Pressure pushes matter away from others. Dark matter drags invisible threads across the cosmos. Energy flows along pathways carved by these interactions. Together, these forces generate a repeating architecture, a cosmic fingerprint. But to understand the universe's hidden code, we must go deeper still. The cosmic web is shaped by something we cannot see, something that does not emit light, does not absorb light, and does not interact with light at all. This mysterious entity is dark matter. Although invisible, dark matter forms more than 80% of the universe's total mass. It creates halos around galaxies, anchoring them like invisible cages. Without dark matter, galaxies would simply fly apart. Stars would drift into the void. No structure would survive. If ordinary matter is the paint, dark matter is the canvas. It behaves according to the same rules that shape weather, ecology, markets, and minds. The same mathematics that describes neural networks can describe cosmic networks. The same logic that explains branching in trees explains the branching of filaments. The universe writes its code with breathtaking consistency. As we look at the cosmic web, we begin to understand this code, not as a set of equations, but as a philosophy. A way nature organizes itself, a blueprint for complexity. A bridge between the quantum and the cosmic. A reminder that while we are small, we are not separate from the universe, we are participants in its code. As we advance deeper into the hidden architecture of the universe, we begin to recognize a profound truth. The universe does not merely contain structure. The universe is structure. A vast interconnected system where every component, from the tiniest quantum fluctuation to the largest galactic supercluster, responds to the same underlying principles. These principles create form, guide motion, and shape evolution. They are the grammar of the cosmic code. To understand this fully, we must look beyond the static shape of the cosmic web and examine the processes that govern its behavior. Like any complex system, the universe doesn't just exist, it evolves. It grows, restructures itself, collapses, expands, and reorganizes. Each of these transformations reveals another layer of the invisible code. Consider the delicate balance between gravity and expansion. Gravity pulls matter inward. Expansion pushes it outward. These two forces act like cosmic sculptors, each carving the universe in opposite directions. When gravity dominates, galaxies collide, merge, and collapse into more compact structures. When expansion dominates, galaxies drift apart, filaments stretch, and voids expand into vast deserts. The interplay between these forces is not chaotic. It follows precise mathematical rules, rules that define how structure forms and how it changes. If gravity were slightly stronger, the universe would have collapsed long ago. If expansion were slightly stronger, galaxies would never have formed. The fact that we exist at all means that the balance between these forces is finely tuned. This fine-tuning does not imply design. It implies that the code of the universe is incredibly sensitive. Small changes in the parameters of physics produce dramatically different outcomes. The universe we inhabit is one where conditions naturally allow structure to flourish. Now consider the role of entropy, the tendency toward disorder. Entropy increases over time, driving the universe toward greater dispersion of energy. But entropy does not destroy structure. Instead, it guides the formation of new patterns. Stars burn hydrogen into helium, releasing energy. That energy radiates outward, enabling chemical complexity, planetary formation, and eventually life itself. Entropy, often seen as a destructive force, becomes a catalyst for organization. The cosmic web is a product of entropy just as much as it is a product of gravity. The universe evolves not toward simplicity, but toward more intricate forms of complexity. Patterns emerge, stabilize, and then give rise to new patterns. This is not randomness. It is a cascade of self-organizing processes. Let's consider another example. Turbulence on Earth. Turbulent flow seems chaotic. Whirling eddies in a river, swirling clouds in the sky. Yet turbulence follows rules. It creates vortices of specific sizes. It transfers energy in predictable ways. At the smallest scales, turbulence often settles into fractal patterns. Now, scale turbulence up to cosmic proportions. Gas clouds falling into galaxy clusters generate turbulence on absolutely immense scales. These turbulent flows amplify magnetic fields, distribute energy, and shape how galaxies form within clusters. Turbulence in galaxy clusters is like weather on cosmic scales, a dynamic system following mathematical patterns that repeat across time. Again, we see the code repeating. Chaos produces pattern. Pattern shapes structure. Structure guides evolution. But perhaps the most elegant expression of the cosmic code lies in symmetry. Symmetry is not merely aesthetic. It is fundamental to the laws of physics. Every force we know is governed by a symmetry. Electricity and magnetism are two aspects of a deeper electromagnetic symmetry. The strong and weak nuclear forces reveal hidden symmetries when studied at higher energies. Even conservation laws emerge from symmetry. The conservation of energy arises from the symmetry of time. The conservation of momentum arises from the symmetry of space. Symmetry is the backbone of the cosmic code. Yet the universe is not perfectly symmetrical. If it were, nothing would exist. Perfect symmetry is sterile. It lacks contrast, variation, and differentiation. It is the breaking of symmetry that creates complexity. In the early universe, symmetry was broken in countless ways, producing the diversity of particles, forces, and structures we see today. This is one of the most remarkable features of the code. The universe emerges from broken symmetry, using imperfection to build complexity. A slight imbalance between matter and antimatter created all the galaxies. A tiny asymmetry in density produced the cosmic web. An infinitesimal shift in quantum fields created the seeds of star formation. It is as if the universe uses imperfection as raw material. Each flaw becomes the start of a new structure. This pattern extends down to quantum mechanics. The quantum world is filled with fluctuations, tiny uncertainties that ripple through space and time. These fluctuations are not errors or noise. They are the raw ingredients of structure. When magnified by cosmic expansion, they become the filaments and voids that define the large-scale architecture of the universe. We begin to understand the universe's invisible code is not a rigid blueprint. It is a set of rules that allow complexity to emerge naturally. It is both deterministic and creative. It imposes order and allows freedom. It shapes the world and is shaped by it. To appreciate this fully, we must examine the role of networks. Networks appear everywhere in nature. Neural networks connect the brain. Ecological networks connect species. Electrical grids connect cities. Social networks connect people. These networks share certain features. Yet the universe is not perfectly symmetrical. If it were, nothing would exist. Perfect symmetry is sterile. It lacks contrast, variation, and differentiation. It is the breaking of symmetry that creates complexity. In the early universe, symmetry was broken in countless ways, producing the diversity of particles, forces, and structures we see today. This is one of the most remarkable features of the code. The universe emerges from broken symmetry, using imperfection to build complexity. A slight imbalance between matter and antimatter created all the galaxies. A tiny asymmetry in density produced the cosmic web. An infinitesimal shift in quantum fields created the seeds of star formation. It is as if the universe uses imperfection as raw material. Each flaw becomes the start of a new structure. This pattern extends down to quantum mechanics. The quantum world is filled with fluctuations, tiny uncertainties that ripple through space and time. These fluctuations are not errors or noise. They are the raw ingredients of structure. When magnified by cosmic expansion, they become the filaments and voids that define the large-scale architecture of the universe. We begin to understand the universe's invisible code is not a rigid blueprint. It is a set of rules that allow complexity to emerge naturally. It is both deterministic and creative. It imposes order and allows freedom. It shapes the world and is shaped by it. To appreciate this fully, we must examine the role of networks. Networks appear everywhere in nature. Neural networks connect the brain. Ecological networks connect species. Electrical grids connect cities. Social networks connect people. These networks share certain features. Yet the universe is not perfectly symmetrical. If it were, nothing would exist. Perfect symmetry is sterile. It lacks contrast, variation, and differentiation. It is the breaking of symmetry that creates complexity. In the early universe, symmetry was broken in countless ways, producing the diversity of particles, forces, and structures we see today. This is one of the most remarkable features of the code. The universe emerges from broken symmetry, using imperfection to build complexity. A slight imbalance between matter and antimatter created all the galaxies. A tiny asymmetry in density produced the cosmic web. An infinitesimal shift in quantum fields created the seeds of star formation. It is as if the universe uses imperfection as raw material. Each flaw becomes the start of a new structure. This pattern extends down to quantum mechanics. The quantum world is filled with fluctuations, tiny uncertainties that ripple through space and time. These fluctuations are not errors or noise. They are the raw ingredients of structure. When magnified by cosmic expansion, they become the filaments and voids that define the large-scale architecture of the universe. We begin to understand the universe's invisible code is not a rigid blueprint. It is a set of rules that allow complexity to. Yet the universe is not perfectly symmetrical. If it were, nothing would exist. Perfect symmetry is sterile. It lacks contrast, variation, and differentiation. It is the breaking of symmetry that creates complexity. In the early universe, symmetry was broken in countless ways, producing the diversity of particles, forces, and structures we see today. This is one of the most remarkable features of the code. The universe emerges from broken symmetry, using imperfection to build complexity. A slight imbalance between matter and antimatter created all the galaxies. A tiny asymmetry in density produced the cosmic web. An infinitesimal shift in quantum fields created the seeds of star formation. It is as if the universe uses imperfection as raw material. Each flaw becomes the start of a new structure. This pattern extends down to quantum mechanics. The quantum world is filled with fluctuations, tiny uncertainties that ripple through space and time. These fluctuations are not errors or noise. They are the raw ingredients of structure. When magnified by cosmic expansion, they become the filaments and voids that define the large-scale architecture of the universe. We begin to understand the universe's invisible code is not a rigid blueprint. It is a set of rules that allow complexity to emerge naturally. It is both deterministic and creative. It imposes order and allows freedom. It shapes the world and is shaped by it. To appreciate this fully, we must examine the role of networks. Networks appear everywhere in nature. Neural networks connect the brain. Ecological networks connect species. Electrical grids connect cities. Social networks connect people. These networks share certain features: hubs, links, flows, and self-reinforcing patterns. They grow organically, adapting to their environment. The cosmic web is the largest network in existence. Its filaments are links. Its clusters are hubs, its flows of matter are currents, its evolution is governed by feedback loops. Remarkably, the mathematics of network theory can describe the cosmic web with surprising accuracy. The same equations used to model the internet or the brain can describe galaxy clustering. This reveals something extraordinary. The universe organizes itself using universal principles of connectivity. This insight leads us to a deeper realization. The structure of the universe is not arbitrary. It follows the geometry of optimal efficiency. Filaments form because they minimize energy. Voids expand because they reduce density gradients. Clusters grow because they maximize gravitational stability. The cosmic web is efficient, stable, and interconnected. It is a cosmic optimization. But the code operates at smaller scales as well. Within galaxies, stars form in molecular clouds, cold regions of gas that collapse under their own gravity. These clouds fragment into filaments, reflecting the same geometry observed in the cosmic web. Within these filaments, stars form in clusters, mirroring the clustering of galaxies. Even the distribution of planets around stars follows patterns shaped by disk dynamics and angular momentum, creating orderly structures like rings, gaps, and spirals. The more we explore, the more the universe resembles a vast fractal, patterns nested within patterns, each scale echoing the structure above and below it. As we widen our perspective, one idea becomes inescapable. The universe is not just governed by a hidden code. The universe is that code made visible through structure. We are living inside a mathematical expression, a geometry unfolding across space and time. And yet, this vast, complex system gives rise to something even more remarkable. Inside the filaments of galaxies, around stars formed in molecular clouds, on planets shaped by gravitational dynamics, life emerges. Biology is not separate from the cosmic code, it is the continuation of it. The same principles of symmetry, self-organization, network dynamics, and fractal geometry shape ecosystems and cells. Life is not an anomaly, it is a manifestation of the universe's tendency toward complexity. Consciousness itself, born from billions of interconnected neurons, is an expression of the same network principles that shape the cosmic web. We begin to see ourselves not as observers of the code, but as participants in it. We are one of its patterns. As we continue peeling back the layers of the universe's hidden architecture, we begin to see that the cosmic code does not simply shape matter. It shapes possibility. It governs not only what exists, but what can exist. Every galaxy, every star, every atom, every living cell is allowed by the rules of this code. And many other potential forms we may not even be able to imagine, are forbidden by it. To understand this, we must explore the concept of constraints. This resemblance is not superficial. It reflects a deep truth. Both systems optimize connectivity while minimizing energy. Both systems require efficient communication across vast networks. Both grow through self-organization, not deliberate design. The universe, in a sense, thinks like a mind. Not because it is conscious, but because both the universe and the mind obey the same principles of complexity. And this leads us to a profound insight. The emergence of consciousness is not separate from the cosmic code. It is one of its natural outcomes. Life, and eventually mind, arises from the same patterns that govern galaxies. The same principles that shape filaments shape neurons. The same rules that organize matter organize thought. When we look at the universe, we are not looking at something foreign or distant. We are looking at the larger version of the system that produced us. We are the cosmic code made self-aware. This awareness gives us a unique vantage point. Unlike the stars, planets, or galaxies, we can reflect on the structure of the universe. We can observe its patterns, decode its rules, and understand its origins. In doing so, We close a loop that began nearly 14 billion years ago with the first quantum fluctuations. Those fluctuations eventually became galaxies. Galaxies birthed stars. Stars forged heavy elements. Those elements formed planets. On one such planet, chemistry began to replicate itself. Replication became evolution. Evolution became consciousness. Consciousness became curiosity. And curiosity led us back to the stars. This is the elegance of the cosmic code. It contains within it the seeds of its own discovery. The universe shaped us, and now we are shaping our understanding of the universe. The same code that organizes filaments allows neurons to fire. The same symmetry that shapes atoms gives rise to thought. The same patterns that form galaxies form ideas. We are fractal echoes of the cosmos. As we stand here contemplating the structure of the universe, we are participating in a grand cycle. We are the universe examining itself, seeking its own rules, deciphering its own patterns. This makes our exploration not only scientific, but deeply philosophical. It is a journey not just outward, but inward. A journey that connects the smallest quantum vibration to the largest cosmic structure. A journey that reveals that everything, matter, energy, life, thought, is unified by a single, invisible code. And we are only beginning to understand it as we journey further into the universe's hidden architecture. We begin to understand something profound. The cosmic code is not simply a set of rules that govern matter. It is a logic that governs transformation. A logic that shapes how the universe changes, adapts, rearranges itself, and evolves from simplicity into complexity. To appreciate this, we must recognize that the universe's structure is not static. It is dynamic. It is constantly shifting, responding to forces both visible and invisible. Galaxies collide. Filaments stretch, clusters merge, voids expand. The architecture of the cosmos is alive with movement, but the movement is not random. It follows clear pathways, guided by the geometry of the cosmic web. Let's consider how galaxies move through this invisible lattice. They drift along gravitational currents, flowing through filaments like fish swimming through underwater canyons. Their paths are not straight lines. They curve and twist as they respond to the gravitational influence of surrounding matter. These trajectories reveal the shape of dark matter, the scaffolding upon which the universe is built. Dark matter does not merely exist. It dictates how matter arranges itself. It forms gravitational wells deep enough to shape the motion of galaxies. Without dark matter, galaxies would not hold together. Their rotation would tear them apart. And yet, dark matter cannot be seen. It does not shine, reflect, or absorb light. It interacts only through gravity. This invisible gravitational framework creates the backbone of the cosmic code. It is the silent force guiding the motion of galaxies, shaping the filaments, forming the clusters, and carving out the voids. The visible universe is only the decoration. The dark matter structure is the skeleton. Now imagine watching this skeleton evolve over billions of years. In the early universe, dark matter is distributed almost uniformly with slight fluctuations. As time progresses, these fluctuations grow. Regions that are slightly denser create stronger gravity, pulling in more matter. Regions that are slightly emptier become voids. This process accelerates, amplifying the structure. The universe behaves like a complex network growing from simple initial conditions. These growth patterns mirror those seen in entirely different systems: the branching of rivers, the development of roots, the formation of fungal networks, the wiring of neural circuits. Why do such different systems produce such similar structures? Because they are solving the same problem: how to distribute resources efficiently in a dynamic environment. For rivers, the resource is water. For roots, it is nutrients. For neurons, it is information. For the universe, it is matter, and the solution across all systems naturally takes the form of branching networks, hubs, and flows. These patterns are not imposed from the outside, they emerge from within. They are the result of self-organization. This idea that complexity arises naturally from simple rules is one of the most important concepts in modern science. It suggests that the universe does not need detailed instructions to create structure. It only needs basic laws that guide how components interact. When these interactions repeat over time, patterns emerge spontaneously. This leads us to an astonishing realization. The universe is inherently creative, not conscious, not deliberate, but creative in a mathematical sense. Given a set of rules, it generates structure. Given time, it generates complexity. Given enough complexity, it generates life. The code is not static, it is generative. To understand how generative the code is, we need to zoom in again, this time to the level of stars. Stars form from the collapse of molecular clouds, vast regions of cold gas scattered throughout galaxies. These clouds collapse because gravity begins to overpower internal pressure, but the collapse is not uniform. Certain regions collapse faster than others. These regions form filaments, thin, thread-like structures very similar to the cosmic web itself. Inside these molecular filaments, knots of gas become dense enough to form stars. In this way, the birth of stars mirrors the formation of galaxies. Both arise from the convergence of matter along filamentary structures. Both arise from the balance of competing forces. Both reveal the same underlying geometry. The repetition of this geometry throughout different scales is one of the clearest signatures of the cosmic code. It suggests that the universe's structure is not arbitrary. It is deeply rooted in the mathematics of stability and flow. A stable pattern repeats. An efficient pattern repeats. A natural pattern repeats. This is why fractals appear everywhere. They are not esoteric designs. They are the simplest, most efficient solutions to complex problems. Now, consider the life cycle of galaxies. Galaxies evolve. They collide and merge. They accrete gas, form stars, and eject material through powerful winds. These processes reshape galaxies over billions of years. Yet throughout this evolution, galaxies retain certain structural features: spiral arms, bars, halos, disks. These structures persist not because they are static, but because they are dynamic equilibria, patterns that remain stable even as their components change. Spiral galaxies maintain their arms despite the motion of their stars. Bars form and dissolve in response to shifts in gravitational balance. Halos maintain their shape as dark matter flows in and out. The persistence of these structures reflects the resilience of the cosmic code. It is not brittle. It adapts. It is not rigid. It evolves. It is not fixed. It grows. This adaptive nature becomes even clearer when we examine cosmic collisions. When galaxy clusters collide, the event is spectacular. Trillions of stars pass through each other without colliding. Because stars are tiny compared to the vast distances between them, gas clouds, however, crash and heat up, creating shock waves. Dark matter continues moving through unaffected, revealing its invisible nature. These collisions reshape the cosmic web. Filaments bend, clusters merge, and new structures emerge. The network reorganizes itself, but always maintains its interconnected geometry. The code bends. It never breaks. Even on the largest scales, the universe shows continuity. The cosmic web today still reflects the layout seeded by the earliest quantum fluctuations. The ripples in the cosmic microwave background, tiny temperature differences measured by satellites, correspond to regions that later became the filaments and voids we see now. This continuity across billions of years reveals a fundamental characteristic of the cosmic code: memory. The universe remembers its origins not in a conscious way, but in a structural way. The patterns set at the beginning persist throughout time, influencing everything that follows. This structural memory mirrors phenomena in other complex systems. In biology, epigenetic patterns persist across generations. In ecology, the history of disturbances shapes the future of ecosystems. In neural networks, repeated patterns become long-term memories. Across all these systems, memory is stored not as explicit information, but as stable patterns that shape future behavior. The universe works the same way. Its memory is geometry. Each filament, each cluster, each void is a fossilized expression of ancient fluctuations. The universe today is a snapshot in a long chain of transformations, each connected to the last. But there is an even more profound aspect of this memory. It allows the universe to build upon itself. Stars enrich the interstellar medium with heavy elements. These elements form planets. Planets give rise to chemistry. Chemistry sparks life. Life develops intelligence. Intelligence becomes aware of the universe. This emergent sequence is not inevitable, but it is enabled by the code. A code that encourages stability. A code that rewards complexity. A code that builds the conditions for curiosity, and curiosity brings us full circle. The universe, through us, becomes aware of its own architecture. It decodes its own geometry. It examines its own patterns. In doing so, it completes a loop that began with the smallest quantum fluctuations. The code gives rise to structure. Structure gives rise to consciousness. Consciousness turns inward to examine the code. We are the way the universe reads itself. As our journey continues, we must now explore one of the most mysterious and profound aspects of the cosmic code, the way information flows through the universe. Because beneath the structure, beneath the geometry, beneath the interplay of matter and energy, the universe is fundamentally a system that stores, transfers, and transforms information. This concept may sound abstract, but it lies at the heart of everything, from the behavior of particles to the evolution of galaxies, from the formation of stars to the emergence of life. Without information, structure cannot be sustained. Without structure, complexity cannot arise. And without complexity, the universe would remain nothing more than an undifferentiated sea of particles. Let's begin with the simplest form of information: patterns. A pattern is not just a shape, it is a constraint on possibility. It tells us what can happen and what cannot. The cosmic web is a pattern. Spiral galaxies are patterns. Planetary orbits are patterns. These patterns are stable only because they encode information about forces, energies, and interactions. But where does this information come from? It comes from the laws of physics, the values of fundamental constants, the initial conditions of the universe, the distribution of mass and energy. This foundational information shapes everything that emerges. Now consider the quantum world. Quantum systems are often described as probabilistic, but these probabilities are not random. They follow precise distributions defined by the wave function, a mathematical object that encodes all possible states of a system. This wave function evolves according to strict rules. In this sense, quantum mechanics is not chaotic, it is deeply structured. Quantum fields store information about particle interactions. Virtual particles constantly flicker in and out of existence, creating tiny fluctuations in the fabric of space. These fluctuations are not noise. They are part of the universal information landscape. When cosmic expansion magnified these quantum fluctuations in the early universe, they became the seeds of the cosmic web. The universe's largest structures are the amplified echoes of its smallest information patterns. This reveals something extraordinary. Information does not emerge from structure. Structure emerges from information. Now let's zoom out again. Galaxies are not just collections of stars. They are repositories of information about their past, when they formed, how they evolved, What interactions shape them? Their shapes, their rotations, their compositions all encode the story of the universe written in starlight and gravity. Clusters of galaxies contain even more information. They reveal how matter flows along filaments. They show the tug of war between dark matter and dark energy. They record collisions and mergers that occurred hundreds of millions of years ago. In their shapes, we can read the universe like a book. Information, however, is not static. It moves. Matter flows from voids to filaments. Energy flows from stars into space. Photons travel billions of light years, carrying imprints of the early universe. The cosmic microwave background, the oldest light we can see, is a map of these early imprints. Tiny variations in its temperature reveal the initial distribution of matter. The geometry of these variations has been measured with extraordinary precision. They match the predictions of simulations based on the cosmic code. The universe is not only structured, it is predictably structured. Now consider entropy, often described as a measure of disorder. Entropy is more accurately a measure of how information is distributed. High entropy means information is spread out, impossible to compress into a simpler description. Low entropy means information is concentrated in specific patterns. The early universe had extremely low entropy. Everything was smooth, organized, simple. As the universe expanded, entropy increased, complexity arose, structure formed, stars ignited, galaxies emerged. Life began. Entropy drives the universe forward, not toward chaos, but toward complexity supported by the flow of information. This leads us to one of the most fascinating concepts in modern physics. The universe may be fundamentally holographic. This idea suggests that all the information contained in a region of space can be described by data encoded on its boundary. In other words, the universe may not store information in its volume, but on its surface, space itself could be a projection of deeper informational principles. While this concept is still theoretical, it hints at a profound truth. The cosmic code might not be embedded in matter. It might be embedded in information itself. Now let's consider how information is transformed. When gas clouds collapse to form stars, information about their density, temperature, and motion is compressed into a smaller, more organized structure. When stars explode as supernovas, that information is released back into the universe, enriching space with new elements. Planets inherit the elemental information produced by dead stars. Life inherits chemical information from planets. And consciousness inherits neural information from life. At every stage, information becomes more complex, more interconnected, more refined. This chain of informational evolution is not accidental. It is built into the cosmic code. The universe is designed by the laws of physics to increase its capacity to store and process information over time. The universe, in this sense, is a computation unfolding across space. Let's return to the cosmic web. Filaments act as conduits for matter, but they also act as conduits for information. The distribution of galaxies along a filament tells us about dark matter density. The temperature of gas within a filament reveals the history of shocks and collisions. The chemical composition of galaxies encodes generations of star formation. Each filament is a library. Each node is an archive. Each void is a page left blank, and together they form the encyclopedia of the cosmos. As observers, we are not separate from this story. Our atoms were forged in ancient stars. Our brains are networks shaped by evolutionary adaptation. Our thoughts are patterns encoded in the firing of neurons. We are informational structures built by the universe to understand itself. This brings us to a profound realization. Consciousness is not an accident. It is an emergent property of complex networks shaped by the cosmic code. Brains organize information in ways that mirror the universe's own methods of organization. The same principles that create long-range cosmic connections create long-range neural connections. The same balance between stability and flexibility found in galaxy clusters appears in neural circuits. The same fractal structure seen in cosmic filaments is reflected in dendritic branching. We carry the code within us. But our role is not merely to exist. Our role is to observe, and observation is a transformative act. In quantum mechanics, observation determines outcomes. In cosmology, observation reveals the universe's hidden architecture. In philosophy, observation gives meaning to existence. We observe because we are made of the same patterns we observe. We understand the universe because the universe shaped our ability to understand. And so, the cosmic code does something extraordinary. It not only creates complexity, it creates understanding. Understanding emerges from complexity. Complexity emerges from structure. Structure emerges from information. Information emerges from the code, and the code emerges from the laws of physics. If physics is the script, the universe is the performance, and consciousness is the moment the performance becomes self-aware. We stand at the intersection of cosmic filaments, biological evolution, and neural networks. We are the bridge between matter and meaning. This is the essence of our place in the cosmic code. As we move deeper into the hidden architecture of the cosmos, we now arrive at one of the most profound questions the universe invites us to ask. Why does the code produce beauty? This question is not scientific in the traditional sense, yet the answer lies in the heart of physics. Across every scale, atomic, biological, astronomical, the structures shaped by the cosmic code are aesthetically striking. Spiral galaxies wind outward with elegant symmetry. Nebulas glow with vivid color. Crystal lattices form precise geometric shapes. Snowflakes, seashells, tree branches, river networks all emerge from mathematical rules that seem almost artistic. Is beauty woven into the laws of nature? Or is beauty simply the human perception of harmony in the universe's geometry? To explore this, we need to examine the concept of optimization. Nature tends towards structures that minimize energy, maximize stability, or efficiently distribute resources. These optimizations produce patterns, spirals, fractals, hexagons, waves that we interpret as beautiful. When a spiral galaxy forms, it is not trying to be beautiful. It is solving an optimization problem involving gravity, angular momentum, and density waves. The result just happens to align with human aesthetics. But why does our brain interpret these patterns as beautiful? Because our brain itself is built from the same code. Neurons branch like trees, synapses form networks like filaments, electrical signals propagate like waves. Our perception, our cognition, our sense of harmony, these are emergent properties of patterns shaped by the same mathematics that forms galaxies. We find beauty in the universe because we are expressions of the universe. This brings us to another layer of the cosmic code, emergence. Emergence occurs when simple interactions give rise to complex behaviors not predictable from the individual parts. A single neuron cannot think, but billions of neurons arranged in a network can generate thought. A single molecule of water cannot flow, but trillions of molecules move together to create waves. A single star cannot form a galaxy, but billions of stars bound by gravity create spirals, halos, and bars. Emergence transforms simplicity into complexity, complexity into pattern, pattern into meaning. The universe, through emergence, becomes more than the sum of its parts. Let's explore an example of emergence in the cosmos. The formation of spiral arms. Spiral galaxies are some of the most stunning objects in the universe. Their sweeping arms appear to rotate like cosmic whirlpools, but the stars within them do not stay in fixed positions. Instead, the arms are density waves, regions where stars bunch up as they orbit, much like cars clustering in a traffic jam. This means the arms are patterns, not objects. They persist even though the individual stars do not. In this way, Spiral arms are a metaphor for emergent behavior. The pattern is stable, even though its components constantly change. The same is true for planetary systems. Planets orbit in stable configurations because gravitational interactions settle into patterns. Rings around Saturn form intricate structures because ice particles respond to resonance. Even the gaps in planetary rings reveal the presence of hidden moons, small bodies exerting periodic gravitational influence. Patterns reveal presence. Patterns reveal causality. Patterns reveal structure. The cosmic code speaks through patterns. Let's now consider the importance of symmetry breaking. Earlier, we saw that perfect symmetry produces simplicity, while broken symmetry produces complexity. But symmetry breaking is also responsible for diversity. Without it, the universe would be homogeneous, featureless, and lifeless. When a supercooled liquid freezes into a crystal, it chooses a specific orientation, breaking symmetry. When a star collapses, irregularities determine where jets form. When a planet cools, fractures dictate continents and oceans. When DNA replicates, tiny errors, mutations, lead to the diversity of life. Imperfection is not a flaw of the code. Imperfection is the code's engine of creativity. The universe uses randomness not to destroy order, but to enhance it. Randomness introduces variation. Variation fuels evolution. Evolution increases complexity. At the cosmic scale, randomness in initial conditions leads to diversity in galaxy shapes, star clusters, nebulae, and planetary systems. The Milky Way looks nothing like Andromeda. Andromeda looks nothing like the Triangulum galaxy. Each galactic ecosystem evolves according to its environment, its interactions, its history. Galaxies have personalities, they have life cycles, they have stories, and all of these stories emerge from the same code. Now let's look deeper into complexity. Complexity is often misunderstood as complication, but in science, complexity refers to the richness of interactions, not the number of components. A galaxy with 100 billion stars may be less complex than a single living cell when measured by interactions per unit mass. Life represents the highest known expression of complexity in the universe. It is where information becomes self-preserving, where structure becomes adaptive, where the cosmic code becomes recursive, capable of modifying itself through evolution. Life is not an exception to the code. Life is the code exploring its own potential. A bacterium navigates its environment through chemical gradients. A fish responds to fluid dynamics. A bird leverages aerodynamic principles. A human being manipulates mathematics. The very language the universe is written in consciousness is the universe performing self-analysis. We are the code turning inward. But to understand how this is possible, we must examine feedback loops. Feedback loops occur when the output of a system influences its own behavior. Positive feedback amplifies changes. Negative feedback stabilizes them. These loops exist everywhere in nature, in ecosystems, climates, economies, neural networks, and yes, cosmic structures. Galaxy clusters exhibit feedback through active galactic nuclei. Supermassive black holes at their centers release enormous energy, regulating gas cooling and star formation. Too much cooling leads to runaway star formation. Too much heating halts star formation entirely. The black hole mediates this balance through feedback. Feedback loops are stabilization mechanisms. They maintain structure. They maintain complexity. They maintain life. At the biological level, feedback loops regulate hormones, metabolism, and neural activity. At the cognitive level, feedback loops create learning and memory. At the societal level, they drive cultural evolution. The cosmic code uses feedback loops to maintain harmony while allowing growth. Now consider the role of phase transitions. Phase transitions occur when small changes in conditions produce dramatic changes in structure. Water freezes into ice. Gas ignites into stars. Hydrogen and helium collapse into galaxies. The early universe itself underwent multiple phase transitions as temperatures dropped, Each phase transition unlocks new potential. Each unlocks new structures. Each unlocks new rules. As the universe cools, new layers of the code become active. At the highest temperatures, only simple particles exist. As the universe expands, atoms form. Later, molecules. Later still, biological systems. The cooling of the universe is like the unfurling of a cosmic sequence where each stage activates a different aspect of the code. Temperature is not just a physical parameter, it is the timeline of structure. Now, we must address a deeper philosophical insight. The cosmic code allows the universe to know itself through us. Human curiosity is not separate from the universe. It is a continuation of the same process that forms galaxies and stars. The neuron firing that asks, "What is the universe made of?" is governed by the same equations that form a spiral galaxy. When you look at the stars, the universe is looking at itself. When you understand a physical law, the code is decoding itself. When you ask a question about existence, the cosmos is thinking through you. We are not observers on the outside. We are expressions on the inside. We are local manifestations of a universal pattern, and this pattern is ancient, vast, and beautiful. As we continue unraveling the hidden architecture of the cosmos, we must explore one of the most intriguing dimensions of the cosmic code, the way structure emerges across time. Not just how things are arranged, but how they become arranged. Because the universe is not merely a spatial construct, it is a temporal unfolding, a dynamic story written over billions of years. Time, in the context of the cosmic code, is not just a backdrop. It is an active ingredient. It enables transformation, growth, collapse, evolution, and emergence. Without time, a structure would never form, patterns would never repeat, complexity would never arise. Let's begin by considering the early universe. In its first moments, temperatures were unimaginably high. The laws of physics as we know them were compressed into a single unified state. Time was young, and the code had not yet begun to express its full potential. But as the universe expanded and cooled, the laws separated, like colors emerging from a bright white light. This separation of forces was the universe's first major phase transition. Gravity split from the strong nuclear force. Later, the electromagnetic and weak forces separated. Each time the universe cooled, it unlocked new rules, new behaviors, new symmetries, new possibilities. The cosmic code is not a static set of instructions. It is a sequence, a progression of laws activated as the universe evolves. This sequence behaves like the unfolding of a complex algorithm. Early in its operation, the algorithm produces simple outcomes: particles, radiation, expansion. As the algorithm progresses, complexity grows: atoms, molecules, stars, galaxies. Later still, higher complexity emerges: biology, ecology, cognition. Time is the axis along which the universe's algorithm expresses increasing sophistication. Now imagine watching this sequence unfold as an accelerated film. You would see the universe begin as a sea of energy, then cool enough to form plasma, then atoms, then stars. Stars would ignite, fuse elements, explode as supernovas, scatter heavy elements into space. These elements would form planets. On some planets, chemistry would ignite cycles of self-replication. Life would appear. Evolution would sculpt diverse species. Eventually, some species would develop brains capable of abstraction, memory, language, and science. This entire progression, from quantum fluctuations to consciousness, is woven into the cosmic code. But why does the universe move toward complexity rather than away from it? The answer lies in entropy. Entropy, often described as disorder, is actually a measure of how energy spreads out over time. The universe moves toward states where energy is more evenly distributed. But in the process of spreading out, entropy allows pockets of order to arise. small islands of low entropy that temporarily defy the general trend. Stars are pockets of low entropy. Planets are pockets of low entropy. Life is a pocket of low entropy. Conscious minds are pockets of extreme low entropy. These pockets arise because the cosmic code makes room for temporary order within an overall increase in entropy. In other words, complexity is not a violation of the code, it is an expression of it. Let's consider the life cycle of stars. Stars convert hydrogen into helium. In doing so, they release enormous amounts of energy, increasing entropy, yet the star itself remains structured, stable, organized. Its internal symmetry persists even as energy escapes. This balance, order maintained while disorder increases, is the hallmark of complex systems. Galaxies behave similarly. They form from collapsing gas clouds, then sustain structure through rotation and dark matter halos. Over time, stars die, black holes grow, and gas becomes exhausted. Eventually, galaxies fade, but while they exist, they maintain a delicate equilibrium, a balance between gravitational attraction, kinetic motion, and cosmic expansion. This persistence of structure, despite entropy, is part of what makes the cosmic code so remarkable. It allows complexity to emerge even in a universe that overall trends towards simplicity. Another crucial element of the cosmic code is coincidence, or more accurately, coincidental fine-tuning. Certain cosmic parameters must align precisely for complexity to exist: the strength of gravity, the rate of cosmic expansion, the mass of electrons, the ratio of matter to radiation, the amount of dark matter, the density of the early universe. These numbers could have been anything, but they are not random. They fall within a narrow range that allows structure to form. This does not imply design. It implies sensitivity. The universe is a self-organizing system that, under the right conditions, gives rise to complexity naturally. This delicate fine-tuning extends even to time itself. The formation of galaxies requires billions of years. The evolution of stars requires hundreds of millions of years. The emergence of life requires stable environments lasting hundreds of millions more. The universe is old, not by accident, but because time is necessary for complexity. Time is the incubator of structure. Let's now shift from cosmic evolution to cosmic interaction. Structures do not evolve alone. They shape and reshape each other. Galaxy clusters exert gravitational influence on nearby filaments. Supernova explosions seed surrounding regions with heavy elements. Black holes release jets and radiation that regulate star formation. The universe is a network not only of structures, but of effects. Cause and effect ripple through the cosmic web, creating chains of influence that span millions of light years. These interactions behave like information transfer in a computational system. Gravity transmits mass information. Light transmits energy information. Gas pressure transmits density information. Temperature transmits thermal information. Every force is a messenger. Every structure is a memory. Every motion is a signal. The cosmic code is implemented through these interactions. In this sense, the universe is not just a physical structure. It is a vast information processing system. Let's consider one of the most extraordinary examples of information flow. Gravitational waves. When massive objects like black holes collide, they warp space-time, sending ripples across the universe. These ripples carry information about their source: mass, spin, distance, and history. When they reach Earth, they are incredibly faint, distorting distances by less than the width of a proton. And yet, our instruments can detect them. Gravitational waves reveal that even space-time itself can transmit information. The fabric of the universe speaks, and we are learning to listen. Now consider another form of information: light. Photons carry information across billions of years. When we observe distant galaxies, We see them not as they are, but as they were. Light is a time capsule. It reveals the history of the universe. It shows us the evolution of structure. It encodes the fingerprints of the cosmic code. When we gather this light through telescopes, we are collecting the universe's memory. When we analyze its spectra, we are decoding the universe's chemistry. It is as if the universe is not only a physical reality, but a computational one. But unlike a static computer program, the cosmic code is adaptive. It responds to initial conditions. It evolves as the universe evolves. It unfolds across time, shaping and reshaping structure. This dynamism is essential to understanding the universe's creative nature. Let's examine one of the most elegant expressions of this creativity, the formation of planetary systems. Around young stars, disks of gas and dust form swirling patterns driven by gravity, rotation, and turbulence. Over time, dust grains collide, stick together, and gradually grow into planets. The architecture of these planetary systems, orbital resonances, spacing, inclinations, reflects the interplay of forces. This interplay is a miniature version of the cosmic web. Patterns within patterns, order within motion, geometry within chaos. Even in the smallest cosmic structures, the code is present. Now turn your attention to the Earth, a small, unremarkable planet orbiting an average star in the outskirts of an ordinary galaxy. And yet, on this planet, life emerged. The laws of chemistry, biology, and evolution gave rise to organisms capable of sensing, reacting, adapting, and eventually thinking. Life represents a new layer of the cosmic code, one in which the rules of physics crystallize into self-replicating patterns. DNA encodes information about form, function, and survival. Natural selection acts as a filter, amplifying patterns that thrive and eliminating those that fail. Over time, life becomes more complex, more capable, more aware. This complexity culminates in consciousness, the ability of the universe to reflect on itself. Human beings, with our capacity for language, mathematics, imagination, and curiosity, represent the code made self-aware. We ask questions, we explore, we create. We attempt to decode the very laws that created us. The universe gave rise to minds capable of understanding the universe. This is perhaps the most astonishing expression of the cosmic code. Now consider the concept of perspective. Every observer in the universe experiences reality differently. A photon experiences no time. A planet experiences gravity as curvature. A black hole experiences mass as geometry. A human being experiences the universe through the filter of senses, memory, culture, and cognition. Despite these differences, the code remains consistent across all perspectives. Gravity behaves the same in every galaxy. Light behaves the same in every corner of the universe. Quantum mechanics behaves the same in every atom. This universality is the foundation of science and the glue that binds the cosmic code. And yet, our understanding is incomplete. The code contains mysteries we have not yet deciphered. Dark matter, dark energy, the nature of space-time, the origin of the laws themselves. These mysteries are not obstacles. They are invitations. Invitations to continue exploring, to continue decoding, to continue participating in the universe's self-discovery. This brings us to the final insight of our journey. The cosmic code is not separate from us. It runs through us. We are its expressions, its instruments, its observers. The atoms in our bodies were forged in stars. The patterns of our thoughts mirror cosmic networks. The curiosity that drives us is an emergent property of universal principles. The universe has spent 13.8 billion years expanding, cooling, structuring, evolving, and eventually producing creatures capable of asking, why? We stand at the frontier between ignorance and understanding, between complexity and meaning, between the finite perspective of the mind and the infinite architecture of the cosmos. When you look at the night sky, you are not gazing at something distant or foreign. You are looking at a larger version of the structure that shapes your own being. You are looking at the geometry from which your thoughts arise. You are looking at a universe that is not merely out there, but in here, woven into every cell, every idea, every question. The cosmic code is not a mystery to solve. It is a relationship to experience. And in understanding it, we understand ourselves. It is as if the universe is not only a physical reality, but a computational one. But unlike a static computer program, the cosmic code is adaptive. It responds to initial conditions. It evolves as the universe evolves. It unfolds across time, shaping and reshaping structure. This dynamism is essential to understanding the universe's creative nature. Let's examine one of the most elegant expressions of this creativity, the formation of planetary systems. Around young stars, disks of gas and dust form swirling patterns driven by gravity, rotation, and turbulence. Over time, dust grains collide, stick together, and gradually grow into planets. The architecture of these planetary systems, orbital resonances, spacing, inclinations, reflects the interplay of forces. This interplay is a miniature version of the cosmic web. Patterns within patterns, order within motion, geometry within chaos. Even in the smallest cosmic structures, the code is present. Now turn your attention to the Earth, a small, unremarkable planet orbiting an average star in the outskirts of an ordinary galaxy. And yet, on this planet, life emerged. The laws of chemistry, biology, and evolution gave rise to organisms capable of sensing, reacting, adapting, and eventually thinking. Life represents a new layer of the cosmic code, one in which the rules of physics crystallize into self-replicating patterns. DNA encodes information about form, function, and survival. Natural selection acts as a filter, amplifying patterns that thrive and eliminating those that fail. Over time, life becomes more complex, more capable, more aware. This complexity culminates in consciousness, the ability of the universe to reflect on itself. Human beings, with our capacity for language, mathematics, imagination, and curiosity, represent the code made self-aware. We ask questions, we explore, we create. We attempt to decode the very laws that created us. The universe gave rise to minds capable of understanding the universe. This is perhaps the most astonishing expression of the cosmic code. Now consider the concept of perspective. Every observer in the universe experiences reality differently. A photon experiences no time. A planet experiences gravity as curvature. A black hole experiences mass as geometry. A human being experiences the universe through the filter of senses, memory, culture, and cognition. Despite these differences, the code remains consistent across all perspectives. Gravity behaves the same in every galaxy. Light behaves the same in every corner of the universe. Quantum mechanics behaves the same in every atom. This universality is the foundation of science and the glue that binds the cosmic code. And yet, our understanding is incomplete. The code contains mysteries we have not yet deciphered. Dark matter, dark energy, the nature of spacetime, the origin of the laws themselves. These mysteries are not obstacles. They are invitations. Invitations to continue exploring, to continue decoding, to continue participating in the universe's self-discovery. This brings us to the final insight of our journey. The cosmic code is not separate from us. It runs through us. We are its expressions, its instruments, its observers. The atoms in our bodies were forged in stars. The patterns of our thoughts mirror cosmic networks. The curiosity that drives us is an emergent property of universal principles. The universe has spent 13.8 billion years expanding, cooling, structuring, evolving, and eventually producing creatures capable of asking, why? We stand at the frontier between ignorance and understanding, between complexity and meaning, between the finite perspective of the mind and the infinite architecture of the cosmos. When you look at the night sky, you are not gazing at something distant or foreign. You are looking at a larger version of the structure that shapes your own being. You are looking at the geometry from which your thoughts arise. You are looking at a universe that is not merely out there, but in here, woven into every cell, every idea, every question. The cosmic code is not a mystery to solve. It is a relationship to experience. And in understanding it, we understand ourselves.